So hey guys, welcome back to my YouTube channel, and today we are going to take another problem in our sliding window playlist, and the question name is maximum of all subarray of size k. So this problem can be found on LeetCode as well as on GFZ, and this problem could have multiple approach. It could be solved using cadence algorithm as well. So but now today we will be solving this problem using sliding window, right? So first thing, right, I already told you, right, whenever we have any kind of problem that talks about subarray kind of thing, we should always first think of sliding window, right? I already told you. And the second thing is k is given and that is fixed, so that means it's a kind of fixed size sliding window. And in the previous video I also talked about how we slide the window. So let's say this is our window. What we do, we take two pointers I and j, and we increment these pointers to slide our window. We already talked about it, right? And when we slide the window, when we hit the window, and then store the answer, and then we slide the window. Okay, fine, that is, I hope that is clear. If not clear, you can refer my previous videos. Okay, so whenever we are given some array and given some k value, so for now we are sure that we are going to solve this problem using sliding window. And the second thing is question saying that we have to find the maximum of maximum values of in an subarray, right? So let's say if we take this subarray, right? Here we could see that our maximum value is 3, and when we take this subarray, right, you can see that again maximum value is 3. And but when we take this subarray, let's say we are taking this subarray from here to here, we are taking this subarray, and then at this point our maximum value will be 5, right? So this keeps goes on, like this keep going, and we keep getting answer, right? So how can we track these values, these maximum values kind of thing, right? So we know that whenever we keep track on some values, we certainly think of some stack data structure. Or whenever we say that next maximum, next is greatest is smallest, or kind of things, or whenever we try to track some values, we kind of think of stack, because stack is the best way to keep track on our incoming or outgoing values, right? So we are going to use stack and sliding window, right? So far this is clear. Now how are we going to simulate that, how this problem will work, or how the sliding window gonna work in this problem? Let's say this is our stack, right? Stack is basically same as an array, but it is like from one end we can add or remove from only one end, right? So this is index 0, this is index 1, this is index 2, this is index 3, this is index 4, let's say. Okay, so I hope that is clear for now. So what we do in sliding window, let me erase this part. What we do in sliding window, we take two pointers, right? We take two pointers. So what I'm going to do, I'm going to take two pointers, I here and j here, right? And at this point I and j are at the same place, and at this point our current window size is 1, right? When when j keeps moving, what we do, we check values and we append it, right? We do some calculation, right? We have already seen that how we approach the sliding window. We take two pointers, and then we perform some while loop, and then we do some calculation, and then we keep increasing the j until we don't hit the window size. Until we hit the window size, we keep increasing j, and then what we do, when we hit the window size, we store the answer, and then we slide the window, right? So this is whole approach of sliding window. I have already talked about all these things in very detail. If you haven't seen those videos, you can prefer previous videos, right? So at this point j is here, right? J is here. So what I do, I append the value 1 in it, right? Now j comes here, because at this point sliding window size is 1, but I want 3, so 1 is less than 3, so I will keep increasing j until we get this window size of 3, right? And now I got the point j here, right? And when I came here, I see that 3 is greater than 1, so what I will do, I will pop this 1 and put 3 inside of it, right? Now I go here and this j becomes here, and I see that is that minus 1, is that minus 1 greater than 3? No, it's not. Then we will not pop anything, we just simply add up things here inside of it, right? Now when our j comes here and I is here, our I is here and j is here, so we see that our window size is 3. That means we hit the window size, and when we hit the window size, what we will do, we will return the answer, our store the answer when we hit the window size, store answer, and the answer will be stack of 0, because whatever value will be at the end will be our maximum values at that current window. So at this point, our maximum value, our value that is at the below, which is at the bottom in our stack, and that is 3. So we will say that 3 is our answer in this window size, right? And now when we store the answer, after that we slide the window, right? So let's slide our window, let's try to slide our window, right? So I is here, j is here. What we do, we increase I and j both, right? I and j both. Before increasing, focus on here, before increasing I need to remove any values of I, array of I, that is involved in our computation, because after increasing I, this value will not be a part of our current window, right? This value will not be a part of our current window, so we will remove it from our calculation if that is present, right? So what we will do, we will check if stack of 0 is equal to array of I, right? If stack of 0 is equal to array of I, that means this value is in our stack, because this value is in our stack. If this happens, this value is in our stack. So if it is in our stack before increasing I need to remove it from our calculation. So I will do stack dot pop, at what index I will pop stack of pop of index 0, right? So I will do that. So what I'm trying to say, let me explain it here. Let's say this is I and this is j, right? And these are some values, and when we slide the value, when we slide our window, what happens, this becomes like this. And what I did, I increase I plus 1 right here and j plus 1 right here, right? And at this point in our current window, right, in our current window, I will be having some calculation, right? And when we increase I, this value will not be a part of our window, right? This value will not be a part of our window, because after sliding our window will be this, right? So this value will not be a part of our window. So I will remove array of I from our computation, right? And then what we do, we append array of j plus 1 in our computation, because that happens already, that automatically happens when we increase j plus plus, right? So whenever we increase I, we remove array of I from our computation, right? So I hope that makes sense. Okay, now let's see some code and it will be crystal clear. I took a stack, this is our stack, let's say this is our stack, and I made an answer array, this is answer array, and as I told you, I took 2 pointers. So you can see here I defined 2 pointers, and then I will run our loop while j is less than length of r. What I will do in stack, basically whenever we try to solve some stack, what we do, we first we pop, and then what we do, we take answer whatsoever. If some answer is there, we we store answer and then we push, right? But in our this case what we do, we pop first, because if any number, let's say in our stack 1 is already there, right? In our stack 1 is already there, let's say, but if any bigger number comes, that want to be the maximum in that subarray, so it will pop 1 and it will take place at the 1, right? It will go directly to the bottom after popping the 1, so it will become like this. So the same thing is happening here, l dot pop, and then we are appending it, right? We after popping everything, we are appending in that. And if we don't hit the window size at this point, if we don't hit the window size, we will keep increasing j, and as soon as we hit the window size, what I will do, I will store the answer, and l of 0, that means stack of 0 will be the our answer, so I will store the answer in our answer array, and then I will check if array of I in our computation, I will remove that, right? If array of I in our computation, we will remove that, and after removing I will increase I plus 1 and j plus 1. So that is basically means we at this point we are sliding window, we are sliding our window, right? We are sliding our window. And hope that is clear to you. If any doubt, please let me know in comment box, and I will definitely reply you. Thanks for watching this video. Have a nice day.